Okay, so next up we're going to be looking at the inverse of exponential functions, right? So we need to know that exponential functions, when we inverse them, will end up with log functions, okay, log graphs. So first I'm just going to chat a bit about how to go about using logs. So logarithms we'll use anytime we need to determine what an exponent is. So basically if my variable is an exponent and we need to determine it, that's basically when we'll use logs. So well, we know from grade 8 to 11, maybe 8 to 11, that when we need to solve for a variable that's in an exponent, what do? We get my base with my exponent alone on one side equal to everything else. Then we'll get my bases the same, right? And then we'll drop my bases, so x must be equal to 10. But what happens when we can't get my bases the same? How do I then determine my exponent? So let's say, for example, that was 2 to the x equals to 900. So we know that there's no integer that we can plug into x that will give me 900. So 2 to no power, basically, that's an integer, gives me 900. So that's when we will use logs, right? So the log law is as follows, or at least the rule is as follows. There are log laws. You don't really need to familiarize yourself with them because as long as you know the rule, you should be fine. And the function we'll use on our calculator will do most of the work for us. But if I say that I have a to the power of x equals to b, and remember the main goal here is to solve for x, my exponent, then x will be equal to log base a b, right? And that's how we will determine that. But it's literally just a flow, right? So I'll say like the x comes down, the a goes to the bottom, and the b goes to the top. It's a flow, right? So let's do that for this. We'll say that this x is what we're solving for, comes down, so it'll be x equals to log, that 2, base goes to the bottom, 2, and then that 900 goes up over there. So on your calculators, which mine is somewhere over here, on your calculators, there's 2 log functions, so you'll use the one that's on the bottom of the screen, and then you will type in 2 as your base, then the 900, and we'll see that x, in fact, is equal to 9,81. Right, so that's basically how you're using logs. Just remember, it's a flow, right? It all flows. X comes down, the base goes to the bottom, and the b goes to the top. Okay, so why is this important for exponential functions? Because we know that we need to, when I find the inverse, switch the positions of x and y and rewrite it in terms of y. So that's why this is important, because I'll do an example of inversing a exponential function. So let's say that the exponential function we've been given is f of x is equal to 2 to the x plus 1 minus 3, right? They now ask us to find the inverse of that function. We know first thing I'm going to do is rewrite this as y equal to, because I just want to be working with y's and x's. I don't want f of x there. Once I look for my inverse, what do? Switch the position of x and y. So now x will be equal to 2 to the y plus 1 minus 3. But now I need to get my y, positive y, equal to everything else, because that's what functions look like, right? So first thing I'm going to do is I'm going to bring my 3 over. It's going to become x plus 3 equals to 2 to the y plus 1. And now we see that my variable is in the exponent, right? And this is where I will now use my log rule. If I want my variable as an exponent to come down, I'm going to need to use logs. So remember, it's just a flow. Y plus 1 comes down, 2 goes to the bottom, x plus 3 goes to the top, right? It's a flow. So y plus 1 log 2 goes to the bottom, x plus 3. Right, last thing to get my y alone, I'm just going to bring my 1 over. So therefore, y is equal to log base 2 x plus 3 in brackets minus 1. Don't forget to use my proper notation. F to the negative 1, x equals to log base 2 x plus 3 minus 1. Right, and this will then be the log graph. Remember though, just keep in mind that everything switches, right? when we're inversing. So again, I'm going to repeat, my x-intercepts of my normal graph will become my y-intercept, and vice versa. My domain will become my range, vice versa. And even your asymptotes will switch. So what was your horizontal asymptote will now become your vertical asymptote, which is very important to keep in mind for exponential functions, because we know exponential functions has a horizontal asymptote. So now, with my log graph, I will have a vertical asymptote. Okay, I'm just going to do one more, and then that is basically inverses. So let's do another one of the log graphs. So let's say they gave me g of x is equal to 3 to the x plus 2. I need to find what g to the minus 1x is, the inverse. First thing I do, I change it to y and x solely, switch my position of my x and y, rewrite just in terms of y, bring my 2 over first, that's x minus 2 is equal to 3 to the y. I want my y to come down positive, so it's a flow. Right, remember though, very important, you see how I grouped that x minus 2 together, because this is 1 when it turns into a log. So that y will come down, that'll be 3, 2, oh sorry, that'll be log base 3 in brackets x minus 2. So therefore my inverse is just equal to log base 3 x minus 2. Right, stay tuned for the example video after this. I'll just chat a little bit about how to answer some questions on inverse functions, and then that's basically it. Right, easy, 8 marks maybe in a paper, but do make sure that you do understand and know inverse functions.